Alright, so the lesson for today is about the segment lengths in circles. Before we start, we need to talk about that there can be chords, of course, we've already talked about chords, that intersect inside of a circle. So we got a chord and we've got a chord. There also can be a tangent that intersects a circle. And when you only have part of that tangent, because a tangent is a line, we call that a tangent segment. So from P to S is called a tangent segment. P to Q is called a secant segment because it touches twice and it's part of a secant because a secant is a line. We call from P to Q the external or the outside part of that secant segment. As you can see, the tangent, the entire part is outside. All of the tangents outside. Whereas the secant from P to Q is outside of the circle, but from Q to R is inside the circle. So now we have a table here at the bottom of page 25. It's basically got three situations that can occur with these. You can have two chords that meet inside. And when that happens, if you want to figure out any part of those chords, if you want to find any length of those chords, like from A to E, or E to B, or C to E, or D to E, there's a formula for that, and that is that part 1 of the first chord times part 2 of the second chord, of the first chord, is equal to part 1 of the second chord times part 2 of the second chord. So again, part 1 and part 2 of chord number 1, and part 1 and part 2 of chord number 2. So in this case, in our picture, it would be like CE times ED would be equal to AE times EB. Now in the second picture, we have two secants, and they are meeting outside. And when that happens, so we have this external part here, and we have this external part here. The formula that you use to find any lengths here is the whole secant times its external part of secant number 1 is equal to the whole times the external part of secant number 2. And finally, we have a secant and a tangent. All right, and then what we have here is a secant and a tangent that meet also outside. This is your external part. So for that one, it's the whole times the external equal to the tangent squared. Let me come up here back to this one. This would be EA times EA times EB. So the external part times the whole thing is equal to EC times ED. Again, the external part times the whole thing. And for this one, it would be PQ, which is the external part, times PR, which is the whole thing, and then PS squared. Now, let's do some examples. So for these the point here is inside, and since it's inside, two chords meeting inside, I'm going to do part times part, so 12 times 9 equals part, which is 18, times part, which is x. And so 12 times 9 is 108, and then we got 18x. We'll divide by 18, and x will be 6. For this one, they're meeting outside. So for the outside ones, we need the whole thing. So this whole thing is x plus 12. So we have the whole thing times the part that's on the outside, which is c to e, which is 12, equal to this whole thing. And 10 plus 11 is 21. So 21 times the part on the outside, which is 11. If I distribute to my 12, I get 12x plus 144. If I multiply 21 times 11, I get 231. I'm going to subtract 144, which gives me 12x equals 87. I'm going to divide by 12, which would give me 7.25. Both of these just ask me to solve for x. And then for our last example, this is outside, but this is a tangent. So you need to do this whole thing, which this whole thing is 37. So 37 times the part that's on the outside, which is 12, equal to the tangent squared. So 37 times 12 is 444. We're going to take the square root of 444, which is going to give us either 2 root 11 if you simplify it, because 4 times 111, sorry, 2 root 111, because 4 times 111 is 444, and square root of 4 is 2. Or if you want a decimal answer, about 21.07. That is actually the notes for this section. That is all that I have. Please ask questions. Please review them. I also am including the video of the homework for these problems, like worked out for you, and an answer key that's just worked out if you don't want to watch videos.